0.5 is the inverse. So this is a new word, the inverse function. So inverse we've never done before. Okay, now we've learned reciprocal. That's different. Inverse, reciprocal. So inverse is a new word. It switches the x and the y coordinates. We are actually switching the x and the y coordinates, physically taking the x and the y and flipping them. So x becomes y becomes x. We're switching it. It's a reflection in the y equals x line. I will show you what that means when we graph one. I'm going to show you on a graph that it actually reflects in the y equals x line. I'll show you what that means. Now, sometimes the inverse of a function is a function. So now we know the definition of function. Function means that for every x, there is one y. Right? It passes the vertical line test. So remember that vertical line test that I was talking about? People were like, which? Okay, so this here, if I have a function, say a quadratic, if I look at this vertically, up and down, there's no place where I will cross that function more than once. If it is not a function, say it looks like this, then vertically, if I was to look down, oh, I'm going to hit it more than once. As soon as it hits it more than once, it's not a function, and this is a function. So we know what a function is. So this is saying that sometimes when you inverse something, right, when you switch x and y, sometimes when you inverse it, it remains a function, and sometimes it does not. What that means is that, okay, today we're going to look at linear. We're going to take our linear function, and we're going to inverse it, and we're going to see if it's still a function. Then in chapter 2, we're going to take our quadratic function and inverse that one and see if it's still a function. So this inverse part is broken up kind of into two parts. One, we're going to start it today, and then we're going to do another part of it in chapter 2, way off in chapter 2. We're going to do the kind of start of it there now. So sometimes it remains a function. If it remains a function, so if the original is a function and the next one is a function, we're going to use this pretty little notation. See that little -1? It does not mean exponent of -1. When it's used on function notation, it means inverse of. So that's inverse of f of x, inverse at g of x, inverse at h of x. So it doesn't mean exponent -1. When it's used on a function, in between, so see how it's in between the f and the x, f of x? And now we learned function notation, that means inverse. You'll get used to this notation. We do the same this warm-up part in grade 12. So you need this definition, and then we extend on it, right? We do more with it. Okay, so here, one more time. The words I said above here. I want you to take all the x and the y coordinates and flip them. So I gave you this graph. So the x coordinate, we're just going to go by ones here. I should have labeled that. Okay, this coordinate here is 3, 3, right? So 3, 3. This coordinate here is -1, 2. I'm just labeling these coordinates. This one is 1, 2, 3, 4, -5, 1. Right? So those are those coordinates. For the inverse, I'm going to take each one of those and switch the x and the y. Literally just switch the x to the y and the y to x. So when I switch those guys, it's still 3, 3. Oh, so it stays 3, 3. This one, it becomes, instead of -1, 2, it'll become 2, -1. And here, instead of -5, 1, it'll become 1, -5. And let's plot those. So 3, 3 is still here. This is 2, -1, and 1, 1, 2, 3, 4, 5. So that's this one. Right, so I plotted them. You don't have to label them like this. This is just my brain thinking it for the first one. And I want you to graph that line. Okay, so take a ruler, because it starts with a ruler, right? So it's the same function, it's just flipped over. And I'm going to show you how that works. Look, so graph it, arrows on the end, right? Match whatever was the beginning, and now it's flipped. But you'll notice it's not flipped vertically, right? It's not a vertical reflection. It's not a horizontal reflection. It is actually a reflection in, I'm going to use light blue here. Hopefully you can see it. Let me know if you can't see the color. In the y equals x line. The y equals x line, right? What's the slope of y equals x? 1. What's the b? B equals 0, right? So m equals 0, 1, and there. So the y equals x line is 0. Slope 1, 1, 1, 1, 1. 1, 1, 1, 1, and then do a dashed line, because it's not part of the graph. This is the y equals x line. Does that make sense? So look how it's reflected. So you remember when you were painting, when you were young and happy, and you would fold your paint line in half? Did you ever do that? And smush them together and open it up and go, oh, look, it's like a butterfly. It's beautiful. See, this reminds you. I had a student once, he took his test and he's like, I'm going to make sure it's right. And he just to make sure. I'm like, that's good. But you can see the fold line. He's like, I want to make sure it's perfect. But yeah, so it's like you folded the paper diagonally along the y equals x, and see how it's a beautiful butterfly? So it's like that. That's a reflection. That creates what's called the inverse. So it's the inverse function is always reflected diagonally in the y equals x line. Yeah.
So instead of the middle, like, try to explain it, like if there was a mirror,
yes,
the mirror is the
that's
y
it.
equals x line?
Yep, that's the mirror line. So it bounces off here, right? So you did those mirror lines in elementary school. You should have done those little mirror things and draw it again, reflected off. Yeah. So exactly. So that's my mirror line. So instead of vertical reflection, horizontal we've done before, it's a nice little diagonal. And it should be perfectly symmetrical along there. If you want to check it, you can kind of look. You don't have to draw that. We'll talk about that more tomorrow. So that's all I wanted, just so you understand what an inverse is. And tomorrow we'll go into more of the graphing and algebra. Okay? That's all.
And the formula just y equals.
We'll go over the formula. Yeah.